This is the closed fields measurement using Apparatus 1. This technique can be used to directly estimate the velocity of the electrons. Please note the precision of this technique is limited for a number of reasons. I am overlaying a white line here to indicate the undeflected path of the beam. Now, as I apply the deflecting voltage at the maximum value of 250 volts, the beam path is deflected. And we will apply magnetic field with current in the counterclockwise direction to deflect the beam back. Please pause the video where you see the beam at the location of the undeflected position and read the current value there for the measurement of magnetic field. That would be around this position. Please note that outside of the region between the electrodes, the electron beam will continue to bend under the influence of magnetic field. So you only have to look at the region between the electrodes. We are doing in the opposite direction in case there's a polarity effect, and also to give us a second trial. Around here is when the beam is no longer deflected. Ideally, both measurements should give the same value. To the extent they're different, that will give a sense of uncertainty of this measurement technique. We will try lower values of accelerating voltage. That was at the maximum value. We have made the measurement with 150 volts before, so we are now doing the closed fields measurement with the accelerating voltage of 150 volts. The deflecting voltage is still 250 volts. And around here is where the beam appears not to be deflected overall. Please pause the video to make the measurements. And we'll change the polarity again for a second measurement. And we apply clockwise current to deflect the beam back upward. And we will try one lower accelerating voltage of about 100 volts. That was the lowest accelerating voltage we have used in other contexts. And this is the most amount of deflection we would get from the applied electric field. And it takes a larger amount of current to deflect this back to undeflected position. And we will change the polarization and try it again. Please note that for measurement of distance between the electrodes, there isn't enough information in this video to calibrate the length scale. What you should do is look at the cyclotron motion video where the same electrodes appear and use the calibrated length scale on that video to measure the distance between the electrodes. And we will have a second video for the apparatus too.